Hello everyone, we are team number 5. Today we are going to talk about our AI Mango project. These are the topics that we are going to go through today. Methodology, evaluation, test results, demo results, discussion, and a conclusion. First, let's look at the methodology. In deep learning classifier, first we try several different models imported from Torch Vision, such as AlexNet, BGG16, ResNext. And second, we modify learning rates based on the validation loss and accuracy. When the loss becomes smaller or accuracy becomes higher, we decrease the learning rate since the model is closer to the optimal. Third, we set the trained models with highest accuracy, which is kind of modified early stopping but without stopping, since the results still have the room for improvement. Fourth, we use this trained model for ensemble learning. Now let's look at the ensemble learning part. Each image is classified by the combination of the models we trained. That is to say, the model votes to decide which class the image belongs to. There are two approaches for ensemble learning. First, simple voting. Each model gets to vote for the class it believes the image belongs to. The class getting the highest vote will be the final decision. Second, weighted voting. In weighted voting, we take model confidence into consideration. For each model, it gives its confidence on which class the model would be in by output three numbers. Each represents the probability of the image being in a class. The probabilities for each class from the old model are then added up to be compared. The class that gets the highest sum is the final decision. In our results, there's no big difference in the performance of simple voting and weighted voting. Next, we are going to talk about the data augmentation. To achieve data augmentation, we implement the deep convolutional GAN. With the interaction between discriminator and generator, we obtain some mango image with some random noise that can be used to train our model. Also, we apply some other image transformation, such as random rotate, which rotates the image to random degree, and center crop, which takes a portion of image from the center, direct to the mango image that the organizer provided, and set them to turn them into extra training sets. We evaluate the performance of each model and choose models with better results, and these are the models we choose, including AlexNet, BGG16, ResNext, GoogleNet, and ShuffleNet. Next, these photos are the results of DC GAN. These are the accuracy of each model we select and the accuracy after we apply the ensemble learning. As you can see, the accuracy of ensemble learning is higher than any of the models. And now this is our demo results. In AI Cup, we achieved 76% accuracy, and in program exam, we get 38 out of 60, which is about 63% accuracy. In discussion, we are going to discuss about three topics. First, that we found that class B is always harder to classify. When training and testing the model we have selected, we noticed that class B mangoes are more difficult to classify. This may be caused by the large difference between mangoes in class B. Many are classified as the wrong class. Second, we are going to talk about is how to vote. When working on ensemble learning, we try a lot of methods, including putting distinct weights on different models based on their accuracies. If one of the models' accuracy is higher than other models after training, then it has higher weights while voting the final decision. Another version is based on how certain the model feel about their decision. Each model has its own probability of which class this mango is in when receiving an image of it. We buff the votes with their own probability of that image. And the reason why we apply this strategy is that we think the model might be unsure about which class to choose since there are multiple classes with similar probabilities. The model simply chooses the one with higher probability. If there is a model with higher certainty about its answer, we give it a better weight and hope to improve the performance. However, the result of all the attempts is quite the same. This is because the models we choose to train get similar results from the same input. So the way to get better results may be improving each individual models or involve other models that can identify different features and thus influence the result of the voting. The last topic we want to discuss is about the accuracy of the data set. When training a deep learning model, the dataset that we use for training must have consistency. However, the datasets provided by the organizer, which include thousands of mango pictures, are labeled by multiple workers. This may lead to the inconsistency of labeling. With this fact, model could be harder to classify the class of mango precisely. And this is the picture that we are going. The picture we are going to show you is the example of the accuracy of data sets. This picture in normal knowledge, we can classify it as class A, class B, and class C. However, the result of the label is the picture that looks the worst is actually from class A, and this is from class C, and this is from class B. And this is the example of the accuracy of the data set we are questioning about. And now we are going to give the conclusion. The first conclusion we are going to say is that training is not easy. It requires parameters modifying, including learning rate, batch size, epoch continuously, and knowing how these parameters work is also important. Second, we found that the design a perfect model is hard. Although we can change some parameter to make our training result better, the training process is actually all performed by the computer. We are not involved in any of the training procedure. So it's quite hard for us to find out how to design a perfect model. The third one is that the limited result also affects our training process. Since our computers are all laptops, so we can only use the resources from Google Colab, and Google Colab have a limitation of resource utilization, and this makes our training process more harder. And this is our presentation. Thank you for your listening.